Hi everyone. So here's practice problem number 4. We have that a lamp is placed on the ground at a distance 17 feet from a point at which a rocket is being launched in the air. So here's where the rocket is being launched in the air and the lamp is 17 feet away. If the rocket travels straight up at a rate of 7 feet per second, determine the rate of change of the angle of elevation theta from the lamp to the rocket when the rocket has a height of 43 feet. So our angle of elevation here I've labeled as theta, and I'm going to call the side H. So we want to find d theta dt, and we know that the rocket is traveling at a rate of 7 feet per second. So we know that dh dt is 7. So we want to find a relationship between theta and our height and this distance between the lamp and where the rocket launched. So using a trig function, we have that tangent of theta is the same as the opposite over the hypotenuse. So we have h over 17. So there's our relationship. We're going to take the derivative of both sides with respect to time. And we're going to have to apply the chain rule. So the derivative of tangent is secant squared. And then the derivative of the inside is d theta dt. And then on the right side, this 1 over 17, that's a constant that can come out in front. And then we're taking the derivative of h with respect to time. So I want to find this d theta dt. I know dh dt is 7. What I don't know right now, and I need to figure out, is the secant squared of theta. So just as a little note over here, we know that the secant of theta is the hypotenuse over the adjacent side. So looking back at my diagram, the adjacent side is 7, but I can use the Pythagorean theorem to find the hypotenuse. So I know that this side over here is 17 squared plus h squared, and if I take the square root of that, I'll have the distance of the hypotenuse. So I know that secant of theta is going to be the square root of 17 squared plus h squared over the adjacent side, which is 17. And let's see. Oh, I know the height. I'm told that the height, h, is 43 feet. So the secant of theta then is going to be 17 squared plus 38 squared, the square root of that, all over 17. Now when I looked at this problem on Newton, it gives the whole thing in terms of a fraction. So I'm going to leave this value here and come back to my equation so we can find the fraction as opposed to the decimal value for this. So when I go back over to the left side here, secant squared then is going to be what I just found, the square root of 17 squared plus 38 squared all over 17 squared times d theta dt equal to 1 over 17 times 7. And so now I want to solve for this d theta dt. So we just need to do some algebra here, but I'm going to let me square this off here. We'll bring this up right here. So if I square both of these sides, square this value here, I'm going to get 17 squared plus 38 squared over 17 squared. That times d theta dt equal to 7 over 17. So if I multiply by the reciprocal to solve for d theta dt, I'll have 7 over 17 times this 7 squared plus 38 squared all over 17 squared. Oh, I'm sorry. That is incorrect. Hold on. I didn't actually take the reciprocal. So let's try that again. This is 17 squared over 17 squared plus 38 squared. So I can get rid of one of these 17s. The 17 can cancel with one of those. And we take 7 times 17, that's 119. And then 17 squared plus 38 squared turns out to be 2138. So this is our d theta dt. It's going to be 119